Okay, so let's just talk at a high level about what the internet is. Okay, a little bit of a history. This goes back to the late 50s, early 60s, United States and the Soviet Union trying to develop a way to electronically communicate to people. The United States Department of Defense developed ARPA project, which then went on to be the internet, effectively. Okay. The ARPANet, ARPANet, started in 1958. Right, if you just read about the history a little bit. And then in the late 70s and early 80s, it really started to grow. The mid-80s, the NSF created the NSFNet. Late 80s, the NSFNet was the primary internet backbone, the passing of messages around from computer to computer. In 1995, the NSF background was decommissioned and privatized, establishing the first 5 networks, one of them here in New Jersey, the network points, and then today the backbone is composed of internet exchange points around the world. Okay, so the internet and the World Wide Web are technically 2 different things. Other ways to use the internet, besides sending messages back and forth, they can be formulated into emails, instant messages, and even voice over internet protocol. Hypertext is the text that contains links to other objects. So if you go to a web page, and from that web page you can see a button or a sentence, and you click on it and it takes you to another page. That's called a hyperlink. Hyperlink takes you to objects on the internet. Okay. So the second phase of the internet, Internet 2, had membership. The first one was originally geared for the military to use. And then the second one was meant for universities and anything related to education, which would include art galleries, museums, libraries, and hospitals. But they could also get data around very, very quickly. Okay, so when looking at different ways to connect to the internet, you could use an Ethernet cable that comes from your internet provider. So your cable company might provide you a modem, and then you can plug an Ethernet cable into your modem and plug that directly into your computer. You could also do it through Wi-Fi, which is where you're doing it through the air. So internet service providers, ISP, would be like your cable company, Comcast and Verizon are popular ISPs, companies that offer you internet access. And then the other thing is how much speed comes through. When you're sending a file, you're uploading a file or downloading a file, the entire file has to come through your internet connection, and it comes through linearly. So how fast it comes in is the speed at which the internet data travels, and that's called your bandwidth, the speed at which the files come through. Okay, so dial-up, I'm not even sure dial-up even exists anymore, but that's where you could go through your telephone. And remember, here's the telephone with the round wheel, which a lot of you probably don't know what that is. You can connect through the internet. You can unplug your telephone and plug the wire into your computer and connect through dial-up. That seems to be gone now. DSL uses phone lines for digital signals. So that's using the existing phone lines but sending the data faster than going through the dial-up service. Cable companies have cables coming into your house that transmits data at much faster speeds. And then you could have Fios, like Verizon, Fios, fiber cables going directly into your home. Fiber cables transmit light. Light moves at faster speed than electricity, so that would be faster than cable, and then the fastest would be broadband access to the internet. Wireless works, so when you're on your cell phone, you're connecting to an antenna somewhere in the area. Like, I don't know what the nearest antenna is to this college campus. But when you pull out your cell phone, you connect to that antenna. That antenna can then connect to a satellite. The satellite can then receive data transmissions and send data transmissions down to a different antenna, which is near your friend who you're sending a text message to. So it could be a municipal Wi-Fi using radio waves inside of cities, eventually sending signals up to satellites. And then a Wi-Fi, which stands for wireless fidelity, but it's basically a way that you can connect directly to the internet without plugging a wire into your device. You can have wireless, you can have Wi-Fi hotspots in public places. Okay. There are different types of web browsers that you can use. Most of you probably know these. Over time, this list will change. Some of these may leave the list, new ones may join. Internet Explorer is made by Microsoft, so if you have a Microsoft Windows system, you're going to have Internet Explorer for free on it. You can download other browsers like Firefox, Chrome, or Safari. Safari is made by Apple. Chrome is made by Google. They all basically do the same thing. They connect you to the internet. Some of them have different features. Some of you may like one over the other. That's fine. So here's different images of the different types of browsers. They all get you to the internet, but you may have your favorite flavor that you like to use. Okay. On mobile devices, some of these same browsers exist and other ones don't. So they're meant for mobile devices. And okay. So now, when you're surfing the internet, there's a programming language called HTML, Hypertext Markup Language. It's a language that basically describes how a web page will appear to you. And if you think about it, web pages are effectively rectangles, right? So let's take a look at this web page. It looks obvious that there is a rectangle across the top here. The rectangle has images and words up here, then the background that turns to blue, and it has buttons here that you can press. You click on those buttons, they're hyperlinked to other pages on the website. So we have this rectangle, we have this rectangle, and now this rectangle in the middle looks like it's broken down into a rectangle here, and a rectangle here. So this is all described, this layout is all described in this programming language called HTML, which we said was Hypertext Markup Language. So you would say the upper rectangle starts at this point, it has this width, this height, its background is white, its background is blue, and the text is in white. You could describe all of that in this programming language. And these files, the HTML files, sit on the server. So if you go to connect to Facebook, Facebook is the server, you are the client. You ask for the file, they send you an HTML file, it appears on your phone, and the instructions in the Hypertext Markup Language file tell your browser how to display the pictures, how to display the website. Your web browser is a program that interacts with the HTML. So if you ever have things that are happening while you're on your while you're looking at a web page, like something pops up, that's a programming language called, the most popular one is called JavaScript, a programming language that runs on your device. It's not running on the server, it's running on your device. And the HTML file includes the JavaScript code in it, and then it runs on your device. When you go to a web page like Facebook.com, they send you what they call the home page, the first page. That's the one where you would type in your email and password and hit enter. Now you're sending a message back to the server and say, now give me a different page. So they're keeping track of the conversation back and forth to know what the next page they need to send to you is. Okay, so plugins, add-ons, and toolbars. So for example, if you've ever gone to a website where they have a flash animation, they're going to play like a little animation on their website. Not a movie, it's not like taking you to YouTube and having you watch a movie. But they're going to do an animation on it, and if your web browser doesn't have Flash on it, which is made by Adobe, a message might pop up and says, you can't view this website because you don't have Flash. Would you like to download it? You can download it. It's made by Adobe, so hopefully you don't download it from some company other than Adobe. And you can download it, and so for example, Flash is an example of a plugin. It's something that would be added to your web browser so that now your web browser can read HTML, which has Flash in it, and make calls to this plugin and run that code. And then add-on, very similar to a plugin, is created for specific browsers to add features to it. So an add-on, when you download that, it's actually making your browser software bigger, not like a plugin which has this thing on the side that only will run if it's cold. And then you could also add different toolbars to your web browsers too. Okay. All right, demonstrate how to navigate the web. All right, I'm not going to demonstrate how to navigate the web. You guys know how to navigate the web. This would be like if you never heard of going to a website. Okay, so if you wanted to, for example, look something up using the website Google, you would go to http://www.google.com, right? Okay, so the protocol, the message, the agreement that you have with the server is going to be using HTTP. Okay, if you wanted to use HTTPS, that's the same as HTTP, except the S means it's secure, and what secure means is that all the messages that you as the client are sending to the server and all the messages the server is sending back to you will be encrypted before being sent. So if anyone along the path reads your message, which they can do if you're like sitting in a coffee shop and you're going through their router, that coffee shop could read the data that's going through it, could block data from getting into the coffee shop, and could read like your password and stuff like that. So if you're using HTTPS, that would be guaranteeing that all the messages being sent back and forth are encrypted. Google is the actual domain, and .com, which is for commercial use, is the top level of the domain. So, okay, so let's see. Okay, so the ICANN is the naming, the referee as far as the namings go. So it's the Internet Corporation that assigns names and numbers. So for example, if you wanted to start your own company, and you're wondering if www, let's say, your first name followed by your last name, .com is available. Maybe nobody else. If you have a common name, chances are your name is taken. If you don't have a common name, it may not be taken. So you could go to the ICANN and say, can I register this domain name? And if nobody else has it in the world, you can have it. And you could go through your ISP company, or a company like GoDaddy or Network Solutions, and you can pay them a fee, $8 a year or something like that. And you can register the name, which basically means you've registered with ICANN that you are the owner of that name. Now, what does that mean? It means no one else can buy that name. What if somebody brings up a web browser and types www.yourfirstnameyourlastname.com and hits enter? Where would it go? It doesn't go anywhere. You would also have to go out and then get a dedicated Internet Protocol address. So if you think about what an Internet Protocol address is, effectively, it's like a phone number, right? So let me just borrow your cell phone for a second. So we have a cell phone. Let's say on your cell phone, you have a bunch of your friends' phone numbers. They're numbers, not names. So if you want to call a friend of yours, you could either type the number in directly, or you could click on their name. Let's say you want to call your friend Mary. You click on Mary, Mary's phone number gets called. How did that happen? Well, there's a table. You put in your contacts, you put your friends' names, and you typed in their phone number. So now if I want to call Mary, I'm not going to call M-A-R-Y, I'm going to call Mary, which means get me Mary's phone number and input those phone numbers into where I'm calling. So it's a mapping of names to numbers. So every computer connected to the internet has a unique number associated with it. The unique number, which is like your phone number, which is unique to you, is called the IP address, the Internet Protocol address. So now if you have a machine that you plugged into the internet and you want to get a dedicated number, a dedicated IP address, you could go to your ISP company and they can assign one to you. Then you could go to, if you have an ICANN, you've registered a domain name, you want to say my domain name maps to this IP address. So now if somebody goes on the internet, types in your domain name and hits enter, they're going to look it up in a table and say that name equals this number, and I'm going to send the request into your computer. So two parts to this. So the IP address, and just in case you're curious, this is an IP version 4, IPv4, IP version 4 IP address. And it consists of 4 numbers that are between 0 and 255. So the reason for this is that it was stored in a 32-bit number. This is going to get a little computer jargon. 32-bit number, because 32 numbers that are either 0 or 1 would be an internet address. And if you had 32 bits, there's about 4 billion different combinations, 4 billion different possible numbers. Well, there's 8 billion people in the world, and many people have several IP addresses. You have one in your car, you have one in your pocket, you have 2 at home when your computer's at home. So it's going to get to the point where these aren't big enough. But just to understand what this is rather than have human beings try to remember the values of 32 bits, we break it down into 4 numbers that range between 0 and 255, and hopefully they're easy to remember. So for example, you can have an IP address of 192.88.98.255. And then you could go out to ICANN and register your domain name and then tell them this name maps to this number. So if anyone tries to go to your name, they'll actually get sent to this number. Okay, so for example, here's somebody trying to get to Amazon.com, right? They want to buy something on Amazon. So what do? They go onto their computer and they type www.amazon.com and they hit enter. And what happens? Well, the first thing that happens is the user's computer sends a message to the DSN server. What is the IP address of Amazon.com? This thing is like your cell phone, which says Mary equals this phone number. This thing says, oh, you want Amazon.com? There you are, 198.88, whatever the number is. Big company like Amazon has many, many servers to handle a lot of traffic. But let's just say this table, which has names, maps names to IP addresses, returns a number, that's it, right here. 176.32.98.166. So they basically looked up in a table, what is Amazon's number? It came back to her, and then came back to her computer, and then a message got sent out. This computer requests data from, here's the number of Amazon.com, not the name, The only point of the name is to go to this thing and have this thing tell me this name equals this number. Now we're sending it out to this number. And then this thing replies and sends the message back to her. Okay. So, all right. So smart searching. Okay. All right. So for example, you could go to Google, and that's probably the most popular search engine in the world. Bing is a Microsoft search engine. Who else has a search engine? Yahoo has a search engine. So what you could do is you can type in a phrase like Eagles. I want to do a search on Eagles. So are you talking about the rock band, the Eagles, the football team, the Eagles? Are you talking about the actual bird, the Eagles? So, so you can go and do a search on that. And this has been going over search engines a little bit, but when you're doing your search, you could put and, or, and not into your search. So a search, you could look for Eagles, not football. And then it would find all the web pages that have the word Eagles in it that are not related to football. And that might be so many, 57 million it looks like. If you're looking for Eagles or birds, anything that mentions Eagles or birds, there would be 628 million of those. If you wanted only websites that talk about Eagles and birds, so that means you're not looking for the football team or the rock band, that would be a much smaller field. So depending on what it is you're looking for and how you phrase it, you could get a lot bigger results and smaller results too. So using the nots and the ands and not so much using ors could help you get a better search results. Okay. Okay, now in the credibility of data, this is a kind of opinion related, but anyway, when you have user-generated content on the internet, the content could be written in forms of blogs, websites, wikis, and social media sites. The question is the information that you're reading on the internet true, right? And when the internet first came out, people would say this, and they weren't kidding around. They'd say, oh, it must be true, I read it on the internet. But that's not the case, necessarily. So blogs are basically a web page that allows anybody who can find the web page to type in anything they want, and they just keep writing, and then someone makes a comment on that, someone makes a comment on that. There's no truth checking at all on blogs. Websites can be created by anybody, and they control the content that's on them, not necessarily true. Wikis are, so wiki is a Hawaiian word that means quick, right? So when Wikipedia came out, the idea was it would be an encyclopedia that could very, very quickly get the data, definitions of things like you would see in an encyclopedia, like a book encyclopedia. And the idea is somebody would say something, like here's the definition of, anything, an amino acid in biology. Somebody would define one, and then a group of people who are so-called experts in the field would comment, hey, that's not true, and then there'd be a vote, and then they'd take the definition down if it's not correct. But at the bottom of the page, it would say all the people who validate this data, saying this is good data. So wikis are, what would be the best way, peer-reviewed. So somebody who's kind of an expert in the field of biology gives the definition of an amino acid, and then other biologists say, yeah, this is correct, or this is not correct, and they can blog about it for a little while. Eventually they resolve it and maybe change the definition, and it gets a little bit better. So wikis could be a little bit more reliable than just like a blog where anybody can comment. Okay, so, all right, so let's see. So if you want to check for credibility, you might want to look at the URL. Is it a well-known URL? Does it end in .edu? That means it's probably an educational institution. Does it end in .gov? It's a government institution. could decide if you trust these or not. Commercial, that commercial just means someone trying to make money. So they're just suggesting here, again, these are suggestions that stick with well-known sources for important information. Use Google Scholar, Scholarly, that's where documents are posted and they're peer-reviewed. Experts in that field have reviewed it and said, yeah, this information is correct. Okay. Other things to look at is how up-to-date is the website. Look at the design of the website. Is it sophisticated? Does it have spelling errors? So I guess they're saying if there's grammar errors and spelling errors, the information is probably not true. Okay. All right. Okay. So yeah, so like I say, this is just a very high-level introduction to the use of the internet. I think all of you know how to use the internet, and just be careful. There's a lot of information on the internet that may not be true, and you just got to watch out for that.